Welcome to the Explainer. Today, we are analyzing absolutely crucial data from Cambridge Mathematics. Whether you are building your foundational skills in syllabuses like 0580 or 4024, stepping up to 0606 or 4037, tackling 4040, or taking on the absolute beast that is AS and A-level Mathematics 9709 and Further Math 9231, there is one undeniable truth. The mechanics of equilibrium, specifically the concept of vector sum zero, consistently trips up even the most thoroughly prepared candidates. We've dug deep into the principal examiner reports, and we are going to reveal exactly what examiners are looking for. Let me paint a picture for you. Imagine two students taking the exact same 9709 mechanics paper. Let's call them Alex and Sam. Alex knows every formula, but absolutely overloads his answers with raw mathematical facts and zero clear analysis. Sam, on the other hand, knows the concepts, but always rushes, completely missing the specific command word requirements in the prompt. Both of these approaches lead to disaster. Today we're fixing that so you never lose those critical, easy marks.
So, here is the ultimate paradox, highlighted time and time again in the examiner data. Why do students who completely understand the mathematical calculations, the raw number crunching, still struggle so much when applying these equilibrium concepts to unfamiliar contexts? Alex and Sam know how to resolve a vector. They know that in equilibrium the forces balance out. You probably do too. You've done the practice, you know the formulas, but on exam day, you look at a problem involving strings, pulleys, and inclined planes, and the marks just slip away. Why? Because Cambridge isn't just testing if you can use a calculator, they are testing your strategic approach. Today, we're going to solve this mystery using the direct, unvarnished insights from the people who actually grade your papers. We are going to transform those red pen marks into green check marks.
Okay, let's dive into this. Here is our roadmap. First, we'll uncover the vector sum secret. Second, we'll explore the method mark strategy. Third, we'll break down the deconstruct, solve, evaluate framework. And finally, we'll tackle the top 3 examiner warnings. Let's get moving.
Section 1, the vector sum secret.
This right here is all about the theoretical architecture that underpins this specific syllabus area. This quote is pulled straight from the syllabus guidance, and it is literally everything you need to know about the Cambridge mindset. Top-performing students exhibit connected, conceptual understanding transferable to unfamiliar contexts. What Cambridge is shouting from the rooftops here is that mere memorization of formulas isn't going to cut it. It will not secure top marks. The syllabus heavily emphasizes causal relationships and cross-topic connections. Top students use a specific structure to build this connection, something we call the PAL framework. Point, evidence, explanation, link. In a mechanics context, your point is stating the equilibrium principle. Your evidence is extracting the exact forces from the diagram. Your explanation is your structured resolution of those forces, and your link is tying it all back to solve for the specific unknown the question asked for. The candidates who achieve significantly higher marks are the ones who can take the fundamental principle of vector sum zero, run it through this framework, and seamlessly apply it to a bizarre scenario they have never seen before.
To achieve that truly connected understanding, the assessment objectives target 3 distinct cognitive domains. First, knowledge and understanding. Do you know the precise definitions? Second, application. Can you use that knowledge to model a physical situation? And third, analysis. Can you logically process that model to find a solution? You must demonstrate mastery across all 3 of these domains, and you do that through command word decoding. When the paper says calculate, it wants a numerical answer. When it says show that, it means the answer is already given, and all the marks are in your step-by-step analysis. This is where Sam always messes up. Sam rushes, treats a show that like a calculate, skips the analytical steps, and gets 0 marks despite arriving at the correct final number. You have to decode the command word to know which cognitive domain the examiner is targeting.
Section 2, the method mark strategy.
Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, this slide introduces a crucial paradigm shift, the method mark strategy. This is a framework where assessment marks are awarded for demonstrating the correct process and systematic sequence, not just getting the final number right at the bottom of the page. Examiners award M marks for method and A marks for accuracy. If you don't show the method, you cannot get the accuracy marks. It is that simple. Examiners highly reward the procedural framework you use to reach a conclusion. If your vector sum zero calculations are completely flawless in your head but invisible on the paper, you are leaving massive amounts of marks on the table. In Cambridge Mathematics, the process absolutely is the product.
Because the process matters so much, the presentation of your information must follow strict conventions. Remember Alex? Alex just dumps a massive block of equations onto the page. No structure, no narrative. Don't be like Alex. Examiners are looking for 4 things. 1. Proper headings to organize your thoughts, like clearly stating resolving horizontally before you write the equation. 2. Correct terminology. Use the exact mathematical language of mechanics. 3. Appropriate formats. And 4. Clear annotation of your working. When you use the Peel framework to structure your math, presenting your information this way isn't just about making the paper look neat or pretty. It develops and demonstrates the exact professional, systematic skills that Cambridge explicitly expects from top-tier candidates. It proves you are in total control of the mathematics.
Executing this strategy successfully relies heavily on your critical data interpretation skills. This is where we run our first interactive workshop challenge, the data scan. Imagine a complex mechanics diagram right in front of you. A block on a rough slope, pulled by a string at an angle, with friction acting against it. You have 60 seconds on the clock. Go. What do you do first? You don't just start writing equations. You extract the data. You pinpoint the mass, the angle of the slope, the coefficient of friction. Then, you interpret the relationships. Which forces are acting parallel to the plane? Which are perpendicular? Finally, you draw evidence-based conclusions to set up your equilibrium state where the vector sum is 0. If you rush this data extraction phase, like Sam always does, your entire systematic sequence is built on a faulty foundation, and the whole thing collapses.
Section 3. Deconstruct, solve, evaluate.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to Ace the Exams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions. Let's map out the exact sequence top candidates use to deconstruct complex vector sum 0 problems. Step 1. Identify the given information. Step 2. Break the scenario into logical steps. Step 3. Solve systematically using your method mark strategy. Step 4. Check for reasonableness. Does the magnitude and direction of this final vector actually make physical sense? This is your ultimate safety net during the exam.
That final step, checking for reasonableness, requires what the syllabus calls evaluative thinking. This is the ability to question assumptions and justify decisions with concrete mathematical evidence. Let's do our second challenge, find the flaw. Listen to this scenario. Sam calculates the normal reaction force of a heavy block on a slope, but forgets to include the vertical component of a pulling string. Sam's equation just says reaction equals mass times gravity times cosine theta. Time's up. Did you spot the flaw? The assumption was wrong. Sam didn't evaluate all the acting forces in that specific plane. When examiners see true evaluative thinking, they immediately recognize an outstanding answer. It separates average robotic responses from truly exceptional ones.
Mechanics of equilibrium can feel super abstract, especially under time pressure. So here's a highly effective memory hack pulled right from the study data. Encode these physical concepts using a visual story method. Instead of just memorizing force vectors as floating arrows on a coordinate plane, visualize a tangible narrative. Picture a massive suspension bridge. The heavy cables are your vectors. If the sum of those vectors isn't exactly 0, that bridge is moving, and that's a disaster. Anchoring the mathematical rules of vector sum 0 in a physical reality helps you recall the concepts instantly when you're staring down a brutal 9709 exam question.
Section 4. Top 3 Examiner Warnings. We went directly into the principal examiner reports to find the biggest stumbling blocks. Across thousands of graded papers, these are the 3 critical failing points. Number 1, candidates forget to include the proper format. Number 2, they forget to check that format and presentation. Why does this happen? Because of poor time management. You need a time management matrix to allocate the right amount of minutes per mark, so you never rush the presentation. Notice that these first 2 massive mistakes have nothing to do with misunderstanding the math. They're about losing easy method marks. And number 3, the absolute grade killer, providing answers that are not specific to the context given in the question.
This slide brilliantly illustrates that third point. On the left, we have generic answers. A student writes down a perfect textbook definition of equilibrium, completely disconnected from the actual scenario. On the right, we have what the examiner is desperate to see: evidence-based answers intrinsically linked to this specific context. Let's do our final interactive workshop, speed writing. You have 30 seconds to mentally draft a Peel paragraph for a particle in equilibrium. Clock starts now. You need to state the vector sum is 0. You need to pull the specific 30-degree angle from the diagram. You need to write the equation resolving horizontally. And you need to solve for the specific tension T. Time's up. If your explanation wasn't about that exact particle at that exact angle, you lose the marks.
So, let me burn this examiner alert into your brain. Always link every single point to the given scenario. You could have the most beautiful procedural framework, your headings can be perfect, and your raw calculations can be flawless, but without contextual anchoring, you simply will not earn maximum marks. The mathematics must serve the specific physical situation you've been asked to solve. Do not give generic textbook answers. Give the answer for the specific problem on the page in front of you.
Which leaves us with this final provocative thought. When you sit down with a Cambridge past paper, ask yourself, are you just calculating the math to find a number, or are you actively proving your systematic analysis to the examiner? Shift your mindset to the latter. Use command word decoding, apply the Peel framework, stick to a time management matrix, and watch those easy marks stop slipping away. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.